Hi everyone, I am Aurora. I am actually a PhD student from the University of Padua in Italy. I work with Professor Massimo Faccoli and Battisti, and they are forest entomologists. Maybe some of you is familiar with them. And here I am collaborating for a period with the SLU remote sensing group. And today I just wanted to present a bit of the work that I am doing for my PhD project. I kept it a bit less technical than other presentation that we saw in these days, but I hope it will be interesting anyway for you. I wanted to first to show a bit of an overview of the situation in Italy, of the bark beetles outbreaks, and then a bit of like some of the works that we did with the satellite imagery, and then more focus on the latest activities that we did with drones on early detection. Very quickly, okay, in Italy, of course, climate change, as in every other place in Europe, mainly temperature increasing in the last decades, and with this gradual increase of temperatures, of course, it affected basically the vegetation health, and we have one of our dominant species is, of course, Norway spruce in the southeastern Alps, and it's been really affected by this. And apart from this gradual and chronic changes in temperature, we also experience more frequent and more intense extreme weather events, mainly droughts. But in 2018, also Vaya happened, and Vaya was a huge wind throw event that hit from Austria all the way, like the majority of Italian Alps, and created, of course, ingent damages. And after Vaya, Ipsipographus came, so we've been experiencing huge outbreaks of Ipsipographus in all the regions affected by Vaya storm, and these numbers are numbers that come from the Italian regions that were affected by this, and you can see that the damages of Ipsipographus are kind of evening out the damages from the Vaya storm, and they are expecting to increase still. These are missing the damages from 2024, so it's a big deal. And what they've been doing, mainly all the regions are conducting their population monitoring using mainly pheromone traps, all over the territories. Just to give you an idea, the threshold that we defined for this area for outbreaks and for defining the epidemic conditions are these 8,000 to 10,000 captures per trap per year. And in the past year, in all of the affected regions, this threshold has been overcome. The phytosanitary services are also doing regular monitoring in all the territories, like field monitoring to report new infestation spots. And this is also paired with the remote sensing, mainly with the satellite Sentinel-2 mostly. And so this kind of monitoring, talking about the remote sensing part, is of course useful with the satellite to assess damages. We mainly detect the latest stages of infestation, so the actual the visible damage that we can see. But of course, a lot of effort, especially in research, has been in the past few years has been focused on the detection of the early symptoms, which is the early phase of infestation is the detection that is useful to limit actual further damages, because it's the detection of the phase when the beetles are still inside the bark, but the symptoms are not visible. And many efforts have been doing with the satellite imagery, but the early phase of infestation is tricky with satellite imagery because of mainly the spatial resolution, as we know. As also someone yesterday said, the problem is with the mixed condition inside 1 pixel. So this, for example, is one of the first studies that we did. We used the multitemporal series of Sentinel-2 images, and we tried to apply a random forest algorithm to try and create a prediction map for a probability of outbreaks, so mapping the probability of outbreaks in a quite big area of the northeastern Italy. And we trained and validated the model with a quite extensive field data that I collected in 2021 and 2022. And the data comprised healthy spots and infected spots, and the infected class included a bit of variability, so in different sizes of the infestation spots, from small to large, and also different phases of infestation. So in the infected class, we included the early stages of infestation and also some mixed conditions, as you can maybe see in this picture. These are examples of some mixed condition that could happen in those infested class. In this study, we were able to obtain overall accuracy for 2022 of 74%. For 2021, it was lower because of there was much more variability in the infected class, and the infected sample was smaller. But still, maybe it's not a super high accuracy, but considering that there was this kind of variability and the presence of early stage of infestation, it shows that it's possible to create at least maps of hotspots of infestation, maybe to also locate areas that are more susceptible to infestation. And but still there is this limitation of the spectral resolution that is not very effective for the early stage. Then we tried also another approach, always with the satellite imagery. We used Planet this time, so a bit higher resolution, 3 × 3 meters. And this was actually not with the classification or anything, but it was more to integrate this with a field data collection gathered through a participatory approach. So we trained the phytosanitary service personnel that during their regular monitoring, they reported the new infestation spots using an Esri app, Survey 123. I don't know if maybe someone is familiar with that. It's a very nice app because it allows you to collect the data in the field, and the data is available almost real time in the online platforms, and it's available for data management and analysis. And then we validated basically if what they reported in the field, we would be able to see also in the Planet's imagery. And the results show that, of course, that are limitations of both methods, just the field monitoring and just the satellite imagery analysis. In fact, with the detectability of the infestation spots was lower for the smaller infestation spots, and also for the early phase of infestation, it remained low regardless of the size of infestation. So in this case, the field monitoring proved more effective for this kind of detection of symptoms. But there was also the limitation of the field monitoring and the usefulness of the integration with the satellite, because the field monitoring reports were very linked to the vicinity of roads and very dependent on the accessibility of the infestation spots. So this was kind to show that it's important to integrate both methods and to not rely on just one thing. Still, the satellite imagery was not super helpful for the early phase of infestation detection. So then, just to the focus of my research aims for the early detection, we decided to go even higher resolution and use drone this time to work with the single tree level and observe the actual spectral changes at the single tree level. And for the detection of the early symptoms, we are also interested in seeing which are the factors that can affect the development of the symptoms in the tree crowns. and of course the detectability. And one of our questions was, okay, but are there only environmental factors or climatic factors like temperature, for example, or moisture that can affect these symptoms, or it may be also population abundance, for example. So we wanted to test that, and we selected the 10 study areas, 5 in epidemic conditions. So if you remember the threshold of before, like high population condition, and 5 in endemic conditions. And in every experimental site, we induced bark beetle attacks with a pheromone bag that we attached on a sample of 5 spruce trees in every experimental area. And then we conducted a monitoring. Once every 2 weeks, we went to control and to check the development of the beetles under the bark, and at the same time we conducted drone flights, and we acquired the multispectral images, and we used those images to calculate a set of vegetational indices. And we were interested in seeing, checking the change and the spectral change and the variation of these indices in time for the infested trees and for the healthy trees, and seeing if we were able to separate these spectral signals, and how early we would be able to separate them. For this study, we focused on the brightest pixels for every 3 crown, and the results show that there was, in fact, a strong effect of the population abundance on the separability of the infested and healthy trees. These are results from a generalized linear mixed model, very simple. And in the epidemic sites, we were able to separate the infested trees from healthy trees very earlier than the emergence of the visible symptoms on the 3 crowns, and during the pre-imaginal development of the first generation of the beetles. In the endemic site, this was not possible. In fact, you can see that we were able to separate infested from healthy trees only at the end of the study period, when all the symptoms were already visible. And this was interesting because, of course, epidemic conditions are the conditions in which we want more to have this kind of, to be able to perform this early detection, to act promptly. And this was interesting to see in our case. Then we conducted like a follow-up study. In the first study in 2022, the experimental sites that we worked in were quite small, 1 to 2 hectares. So we were interested in seeing if we would be able to apply the same kind of method on larger forest areas, and to try bigger. And so we selected these 6 experimental sites, on average 40 hectares, and so thousands of trees this time. Spruce-dominated forest, always in epidemic conditions. And with this time, we did not induce any attack because we were interested in seeing what would happen naturally. And we flew weekly, but for a shorter period, only 1 month in summer in 2023, because it was kind of the temporal window that we selected as based on the previous study, that we were interested in seeing if we would be able to detect this separation between infested and healthy trees. This time the results were not as strong as the previous study. There was a high variability between the sites, and so there are, of course, environmental factors that we have to consider for different experimental sites. But nonetheless, we were able to obtain some detection rates, some high detection rates for the infested trees, and we were able to separate the infested from the healthy trees during the final developmental stages of the first generation beetles. So it was still something. We believe that one of the main reasons why we did not observe the same kind of the same magnitude of results as the year before was the different climatic conditions, because in 2022, the year was much more dry, and the higher rates of precipitation in this year, in 2023, could have an effect on the symptoms, could have slowed down the symptoms. So maybe we would have observed a more clear separation between infested and healthy trees later on in the season. And we were also able to, between these two studies, to find the spectral indices that performed the better in doing this kind of separation. And in our case, it was DRE, which was the only index containing the red edge band, and also the indices containing the green bands. So to wrap up and conclude, in our case, early symptoms were detectable in epidemic population conditions. So we were happy in seeing that we were able to observe the early symptoms before the visible symptoms came up. Maybe for the future, it would be useful to focus on the red edge and maybe also the green bands. I was happy to hear Lamin this morning say that red edge is promising. Maybe we could use some sensors that are more sensible in those kind of spectral, maybe narrower, but those spectral windows. I want to stress again that gather more extensive inventory information is crucial, and it was crucial also for the drone images, because one of the limitations, for example, for 2023, and one of the reasons for which maybe there was some noise, let's say, in the data, was because we didn't have very detailed information of every tree, and I know that there was some silver fir in there, and that maybe have maybe I wasn't able to clear up all the trees that were not actually spruce. There was still more spruce, but there were some trees that I think are silver fir, and that could have messed up a bit. And I would also mention that we should consider also integration with satellite imagery anyway, because there were limitations of the drone, especially on larger area for the processing of the imaging, for the segmentation of the tree crowns, etc. So it would be useful, again, to integrate the technologies if we want to upscale the early detection on larger areas. So I conclude. These are some references if you are interested in checking. I want to thank all the collaborators and all the people that helped me in the work in Italy and here, and thank you for your attention.